Hello, STEM Nation. Jeff here, and welcome to episode number 34 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math to help guide students interested in STEM careers. If you like what you hear on this podcast, I ask that you please share it with a friend. Now let's get fired up today with our guest, John, and I hope our chat will help ignite your passion towards a STEM career. John FitzSimons earned a Bachelor of Science Degree in Electrical Engineering from Purdue University in 1999 and has held various engineering positions at Motorola, Northrop Grumman, and is currently an electrical hardware engineer at GoogleX, the moonshot company. Welcome to the show, John. Fill in any gaps and share a bit of your personal life.
Yeah, thank you, Jeff, for this chance. Yeah. No, I got started at Motorola after graduating from Purdue University, and I was designing cell phones. I spent almost 10 years there. Most of the designs I worked on were for Europe and Japan, so they aren't too well known here. But and one of the first phones I worked on was actually in the Motorola StarTAC family. So I guess go ahead and Google that if you want to see just how far cell phones have come, like in 15 years. And one of the other designs that I worked on was the Motorola A1000, and that is a old smartphone style design with like a touch screen. It still had some physical buttons, but it was an interesting precursor to things like the iPhone and stuff that we have today. Then after about 10 years there, I moved on. I worked at Northrop Grumman. They're a large, defense contractor like Boeing or Lockheed Martin. Maybe the most recognizable design that Northrop does is the B-2 stealth bomber, the big black flying wing. And it's a merger of two companies, Northrop and Grumman. The Grumman part, they made the F-14, kind of like in the movie Top Gun, several other military fighter warplanes like that. But they also made the mail trucks that do residential delivery. So if you actually look closely at most of those, they still have the Grumman logo there on the side. Although those, I'm not seeing as many of them now. They're getting replaced. They're near the end of their service life. I wasn't actually involved in any of those. I worked on a variety of electronic devices, electronic warfare, military aircraft, and electronic warfare is just what it sounds like. You use electronics to either sense the enemy or disrupt their own sensors and communications. So like the dashboard radar detector for avoiding speed traps is an example of that. And just kind of a little bit of an arms race there between the police and detector companies. And, in the military world, it's like that, but kind of times 10. So it's actually kind of an interesting technology to be a part of. And then a couple of years ago, I moved out to the San Francisco Bay Area. I joined Google, and I work for the division known as X, which is their moonshot company. And I'm part of Project Wing, which is a program that creates a system of package delivery based on drones. And then, in my spare time, I play a ton of board games. That probably would have been my, alternate life path of game designer or something like that if I didn't go into engineering. And I got my pilot's license about 10 years ago. I've done some recreational flying here and there. And recently I've been kind of like dabbling and working with my hands. I've taken a few classes on glass blowing and metalworking, and that has been like absolutely fascinating.
John, hey, thanks for that great overview. And let's dig right in here. And hey, you brought up the StarTAC. I used to have a StarTAC, so I guess that shows my age. And so let's dig in here. So from your perspective as an electrical engineer, what are some career opportunities that are out there?
So electrical engineering, it spans a huge variety of disciplines, and each one can be a career path, like all on its own. So I think now a lot of people first think about like digital electronics, in other words, computers, phones. These are like the mostly consumer devices that are part of our lives. But now pretty much everything has a computer in it. So digital engineers are the ones who focus on that sort of information processing. Many of them wind up learning a little bit of software as well, because if you want to design or test around something that's got that like digital smarts in it, you usually need to know how to program it. But that is in some ways like the newest piece of electrical engineering in the big scheme of things. You have radio frequency electronics engineers that their focus is on antennas, transmitters, receivers, all of the wireless designs. In many engineering companies, that's an entirely separate discipline because there's intricacies to learning how to accurately transmit and receive that information. So like radar, broadcast, TV, garage door openers, all that kind of falls in there. And then like the most traditional aspects, if you will, are like analog electronics. So before you used before you recorded stuff on a computer, you recorded it on tape or whatever. And even though some of those technologies have fallen by the wayside, the real world is still squishy and analog. So just about every sensor, every microphone, speaker, audio engineers usually have a strong analog background. So there's always a little bit of that interface there. And then some designs are still purely analog because it's just the best way to do it. And then finally, there's like the very beginnings of EE, the power distribution, like power company, industrial plants, power system designs, motors, generators, all that stuff. But they all have the same fundamental underpinnings. And in some ways, those are kind of useful, but they're a little bit artificial distinctions. But they're like some career roadmaps that people I know have followed.
So as an electrical engineer, John, where would you classify yourself?
I definitely am in the digital, like my background is pretty strongly digital engineering, but at the same time, working on a program for drone delivery. I've done a design for our motor controllers. And then I'm also working with our, radio frequency communication stuff. So it's certainly helped me not to be overly focused in the digital area, to be able to pick up pieces from all of the other engineers that I've come in contact with and learned from, so that I can kind of, develop a project that has all the different pieces of the picture.
So we touched on a little bit. So you classify yourself kind of as a digital engineer, but have also done some motor control. What is your specific area of expertise?
Yeah, absolutely. In some ways, I don't have a specific area of expertise. My focus in my career has been that digital technology, but just maybe to show how it crosses all of these boundaries, I'll just kind of go through all the things that I've worked on. My studies were general EE coursework. An undergrad degree usually touches on each of those aspects that I mentioned. As people who pursue graduate degrees would focus even more in depth, usually on one or two of those. I was mostly interested in digital electronics because, I had worked, grew up with computers, and I thought they were pretty cool. But when I started at Motorola, it actually turned out that the first area of design work I was assigned had to do with power distribution and battery charging. And that's something that I didn't know would be interesting, but it turned out to be. I followed through that for a couple of years, and then color displays and stuff like that were coming out. So I started to work on display and touchscreen technology, and that's a little bit digital in the sense that the information out to the display is all ones and zeros, and but there's things that you have to learn about, like the physics of the display itself and the processor and memory systems that support those. And then as I learned more about that, I started moving back into the central processing units of the cell phone. So high-speed processors, selecting those to be right for the application, and the specific aspects of designing a board that can support gigahertz processor, because as you move up in processor speeds, you have to worry about heat and like radio kinds of phenomenon. And then actually from there, even beginning at Motorola, I just kind of moved, I guess I would say, upstream in the design process. So instead, in the beginning of my career, they'd say, okay, here's the processor we want to use, John, please design the board for it and make sure it has this much memory and that it works. But then I start to get involved in, okay, well, which processor do we want to use? More powerful one. We've got better graphics, faster response, but it'll consume more battery power and take up more space. And so you start to see the bigger picture in everything you're doing. I think the user would love a slim device that has this fast, high resolution screen, but if we can only squeeze a tiny battery in there, it'll probably have a short battery life. And that's so short, on the whole, they'll be unhappy. And so I should speak up and let people know that this is kind of the direction that we're going. And then when I moved from Motorola over to Northrop, I went to the same process in miniature. I did some design work that was under the direction of others to learn the specifics of that industry. There's a huge difference between making millions of devices for the consumer market or making tens or hundreds. But for the military, they have all those customers have really high expectations They want it to work and they want it to do what they ask, but very different in terms of cost and reliability and ruggedness. But all down under the hood, the double E that's going on is very similar. So once I got familiar with the way that designs could work at Northrop and in the military realm, I started to do more of that system level stuff again. One of our designs, so the systems I was building at Northrop were kind of cards in a box. Like if you open up your personal computer, you would see that same sort of thing. And at one point, in a PC, you might have a video card, a sound card, and so on. They seem very unlike each other. But at one point in this design, because I was starting to get this broader perspective, we realized, wow, 3 of these cards, they seem like they're doing very different things, but they're actually all variations on a single design. And we were able to kind of work on those as one thing, and it saved a lot of time, and it caught, so many more differences and that we could have been doing different things, but instead, we were able to kind of focus on it. And there also, I learned a little bit about the practice of engineering. Like, how do you make sure that 2 different people agree on what a design should do? Or how do you make sure that they both agree that that design is complete? And then finally at X, I've kind of been working that almost backwards. In other words, Northrop and Motorola, they both had established products, and we were just trying to figure out how to improve them. Now we're trying to create something new, and our first step is just, wow, we know we want to deliver packages from here to there, but how far, how long, how heavy, we don't even necessarily know what we want. And defining that becomes the first step. And so I'm managing a team of 4 engineers, and that's also a new experience for me. I have to make sure that everyone's working toward the same thing, but is also working on something that's exciting to them and moves them forward in their careers.
All right, John. Hey, thanks for that great overview. And one thing, STEM Nation, that was very subtle in what John was talking about is you have to be open to new ideas, new opportunities. You don't know what's going to come your way. You just have to be open to it and do your best to solve those problems and to be successful out there. John, we're going to move into an area that has you really fired up about electrical engineering or digital engineering or drones.
Drones, I think, are an emerging technology that's got me really excited. Those are the colloquial name for unmanned aerial vehicles, UAVs. And it seems to me like they're kind of on the edge of where, smartphones were several years ago. They're just about to explode in popularity if they haven't done it already. The consumer drones are all about cameras. It seems to have started from videos and images, selfie drones, but also movie filming and inspecting pipelines and industrial stuff that's hard to get to, like wind turbines, and even real estate agents taking photographs of their properties. Now we're seeing things like Project Wing, which is looking at the aspect of moving things around by drone. We have a small delivery operation in rural Australia that's making some deliveries of food and pharmacy items to our customers' yards. And we're hoping that that's more convenient, it's cheaper, it's faster than other ways of moving things around, and more environmentally friendly. But what if, you could just imagine where that's going. What if you could order up a hammer or spare batteries at home when you need them, instead of buying and storing all these things that you just use, once or twice a year, but most of the time they're just sitting on a shelf. It seems really wasteful. So maybe there are a way around that. And the thing that's so exciting to me is that nobody yet really knows what the right answer is. And there's so many things that this could go. Anywhere you have a human pilot, just to start, you could maybe look at pilotless technology, crop dusting or traffic reporting or something like that. But probably the killer app, the thing that we look at and say drones, oh yeah, they're ideal for this, is something that maybe, nobody's thought of yet. And to me, that's incredibly exciting.
So, John, somebody who's interested in drones, because drones they're showing up everywhere. Intel had the drone showing the logo at the opening of the 2018 Winter Olympics, so you could see a glimpse of what drones could do. But somebody who's interested in getting into that field, is electrical engineering the right route, or computer engineering, or computer science? Or is the drone pretty much already been designed and it's going to be more of the systems and the applications? Where do you see that at?
So there's a couple of different ways to think about it. One is if you like drones, if you like things that fly, you might actually look at aeronautical or aerospace engineering or mechanical engineering. Because some of the project, if you look at Google up Project Wing, and you'll see that our drone is kind of a hybrid between an airplane and a standard quadcopter. It's like an H-shaped device that has a wing and it has some rotors. And this is one of several designs that we've considered. So the way of how a drone flies and which drone is best for what application is in some ways not necessarily a solved problem. Then there's the aspects of the control electronics and the payload of the drone. So this is where things get very interesting from an electrical point of view. As long as I would say that as long as you have a background in basic signal processing technologies, which you can get from a number of industries, the same logic that keeps a drone upright in the air is the same sort of thing that allows lane control and automobile cruise control, that allows robot arm control systems. And so the how it flies and the what, like if you wanted to work on, like we're putting cameras on drones right now, but it's like, okay, we need a weather sensor. In some ways, your avenue into this technology can be through any of those focuses that you choose to develop, and drones in particular, because there's something becoming so common, I think is why there's so many possible entry points in there.
So thanks for that great overview, John. And we're going to transition to an aha moment you've had, something that might help our STEM nation. Could you take us to a moment in time of an incredible aha moment you've had at work or your personal life and tell us a story and how you turn that aha moment into success?
There's actually something I was exposed to in college. It was part of my EE coursework. We learned about something called the method of images. I won't go into the details, but if you're trying to figure out what an electrical field in space looks like, the presence of metal initially makes that problem look a whole lot more complicated. It was introduced in school with a lot of math I didn't quite get. So I just focused on, why did they call it that? And looking through it, the answer was, well, the metal surfaces acted just like mirrors. If you had a positive charge in a metal plate, you could solve the problem the same if you took the plate away and put a negative charge where it would seem to be if the metal was a mirror. And that just had a ton of corollaries with the real world. The same equations that describe weight on a spring bouncing up and down describe the flow of current in a tuned radio circuit. And there's all these little intersections. And kind of what it came down to me was the engineering seemed like it was complicated and full of math, but most of the individual concepts were always something I could explain in just a couple of minutes. They're not always intuitive, but they're consistent. And the math is just the details. I'm actually not great at algebraic math. I tend to get lost in the notation and make lots of little mistakes. But that whole experience made engineering, and by extension, some of the other complex things that I've tackled, like flying, just seem so much more approachable.
Would you say that you had to understand the basics? Is that what you're driving at?
Yeah, or not to get lost in the details. So if some things that seem complex really are complex, but a lot of things that seem complex are usually very simple at their center. And if you're having trouble understanding something that seems like there's just a ton going on, maybe there's something under the surface, that sort of basic idea. Once you get your mind around that, that's the scaffold that you can build everything up on. Because to learn it all at once becomes almost impossible.
Okay, John, thanks for that. And we're going to move into STEM Nation heading off to college, John. If you could go back to when you're 18, what are some things you wish you knew back then that you think would help STEMers launch into college successfully?
College is the time to take in as many experiences as you can. I mean, it's thought of, especially in the STEM field, where a degree is usually required to get a job. It's thought of as the place for that specific education, but to me, it's kind of a dry run at life beyond college. So I'd say work on some of the things that you think you're not as confident about in yourself. If you're academically sound, then find other activities to explore. If you're very social, but you're worried about staying ahead in the classwork, join study groups, use all the resources available to you. Everyone wants to see you succeed, so take advantage of office hours and study groups, if you need to, because everyone's kind of in the same boat that you are. I packed my semester is full of classes, and I leaned on AP credit, and to graduate a little bit early. It saved me money and time, but I also didn't get to take too many classes just because I was interested in them, or to meet like a broader cross section of students. So to me, like, college is one time in your life you're going to have so many peers in the same place that you are, and the opportunity cost for trying just about anything is very low. So look into everything that college experience has to offer, and kind of like default to yes as, your answer to check some of those things out.
Yeah, so STEM Nation, I imagine a lot of you are coming into college with a bunch of AP credits, could be coming in as with your first semester done, or even 2 semesters done, starting off basically as a sophomore. But I think what John is saying is you may not want to graduate early. You may want to take other classes to expand your horizon, see what else is out there, and just take it all in. We're going to take a quick pause to thank our sponsor, Audible, who's offering a free audiobook. You can head over to STEMOnFireBook.com, that's STEMOnFireBook.com, to get a free audiobook of your choosing. If you decide to cancel within 30 days, there's no cost, and you keep your audiobook. And we're going to fly into the lightning round. John, are you ready?
Yeah, let's go for it.
What's the best piece of advice you've ever received?
I got it from a friend, best man's speech. He said, whenever you disagree with somebody, always assume good intentions on the part of that partner. Most of the time, everybody really wants the same thing, and nobody wants to see an idea fail, but they might have different plans for the best way to do it. And there's like a skill to kind of figuring out exactly where people are coming from. And so that has helped. That's helped me out quite a lot.
And what is a personal habit that contributes to your success?
I'd say take time to refresh and recharge throughout the day. I can really see my productivity just drop if I'm like hammering on something endlessly, especially if you're under a deadline and usually you want to get it done and you want to get it over with. And so you work on it longer just to get through it. But you're much more efficient. I found I'm much more efficient overall if I take a break, go for a walk, or play a short game or something for a short time before I come back to it. And I get it done faster, and it's a lot less stressful.
And a favorite internet resource or phone app, and why?
Google. I still use regular old Google just for searching information. It puts so much reference there at your fingertips, and I like, there's particular sites that are good for some things, Wikipedia, whatever, but I like having that portal to a bunch of different things, so that, because especially if you're not at all familiar with it, it helps to be able to compare like what 3 or 4 different sources are saying. So, okay, yeah, I'm pretty confident in this answer, or I think this is what applies to me.
And if you could pick one book, what would it be and why?
Book called Surely You're Joking, Mr. Feynman. It's like a autobiography by Richard Feynman. He was a Nobel Prize winner in physics, and he worked on the Manhattan Project. And he was just a colorful character. The book isn't so much about the physics, like not at all. It focuses on his personal experience, at Princeton and Los Alamos, and it kind of gives you the highlight reel of all these interesting personal episodes working on what's this kind of very abstract stuff, and it's very human, and he was a really witty person, so it's also pretty humorous. It's a pretty fun read.
All right, John, and as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
I'd say that ideas that seem obvious to you aren't obvious to everyone. Like you might be thinking of a better or simpler way to do something, and wondering why nobody seems to have picked up on it. And maybe it's because nobody's thought of it yet. Like you're probably smarter than you think.
All right. With that, John, we'll say goodbye.
Goodbye. Thank you very much.
You're welcome, John. I hope you enjoyed our discussion today with John. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on your favorite podcast player. And again, if you're getting value from this podcast, please share it with a friend. Tune in next week where we talk with Megan, who is a mechanical engineer. Until next time, I hope this chat has helped ignite your passion towards a STEM career.